This lesson covers piecewise defined functions and their graphs. A piecewise defined function is defined in pieces by multiple subfunctions, as we'll see in this first example. We want to graph the piecewise defined function f of x equals absolute value of x if negative 4 is less than or equal to x is less than negative 2, f of x equals 0 if negative 2 is less than or equal to x is less than 0, and f of x equals square root of x if x is greater than or equal to 0. Here our subfunctions are f of x equals absolute value of x, f of x equals 0, and f of x equals square root of x. We can rewrite this piecewise defined function as its three parts. If negative 4 is less than or equal to x is less than negative 2, then f of x equals absolute value of x. If negative 2 is less than or equal to x is less than 0, then f of x equals 0. And if x is greater than or equal to 0, then f of x equals square root of x. And let's graph these three parts. We'll start by graphing f of x equals absolute value of x, which is defined on the interval from negative 4 to negative 2. And I will think of negative 4 and negative 2 as being our anchors here. Let's plot our anchors. If x equals negative 4, by the definition f of x equals absolute value of x, y will equal 4. Notice that the less than or equal sign here tells us that this value will be included on our graph, so we'll put a solid point at the point negative 4, 4. And then we'll go on to our other anchor here, which would be at x equals negative 2. Here, y equals 2. And because of the less than sign, we can see that negative 2 will not actually be included in our graphs, but all points up to negative 2, 2 will be included. And so I'll plot negative 2, 2 using an open circle, and I'll graph in the absolute value of x between those 2 points, and this is the first part of our piecewise defined function. Okay, so let's next go on to plot the second part of our piecewise defined function, f of x equals 0, between negative 2 and 0. So here we have our first part of our graph. And then let's use the anchors of x equals negative 2. If x equals negative 2, y will equal 0. This point will be included on our graph. Negative 2, 0. And we'll also graph the anchor. We'll plot the anchor when x equals 0. Y will be equal to 0, giving us the point 0, 0. Here, because of the less than sign, we'll have an open circle. So I'll plot 0, 0, and then we'll have y equals 0 in between those 2 points. Okay, this is the second part of the graph. And finally, we're going to graph the third part of our piecewise defined function, f of x equals square root of x, where x is greater than or equal to 0. Okay, this gives us an anchor of x equals 0. When x equals 0, y is going to be equal to the square root of x, which gives me y equals 0. And so we have the point 0, 0. Do we have an open circle or a closed circle here? Well, the greater than or equal sign tells me that this point is actually included on the graph. And past that point, we'll plot y equals square root of x. And this is the graph of our piecewise function. Notice a couple things here. The domain of our function includes all of the 3 subdomains. The domain here would be x is greater than or equal to negative 4, which would be negative 4 to infinity. And another thing to note, this is a function. Any vertical line by the vertical line test only passes through this function one time. Okay, well, let's go on and have a piecewise function that you can graph on your own. This is defined as f of x equals x squared if negative 2 is less than or equal to x is less than 1, and f of x equals negative x plus 3 if x is greater than or equal to 1.